The electron affinity is the change in energy that occurs when an electron is added to an element. And it's interpreted as a negative number. So what does it mean when it's a negative number? It means that when I add an electron to this system, it can be an element, it can be something else, but we're going to be talking about elements for now. When I add this electron to this element, and it's a negative change in energy, that means energy from the system is released, which means it is now at a lower energy state. So in other words, it's a favorable reaction. It's good for this to happen because it's now at a lower energy state. It's important to remember that anything that happens, the ultimate objective is for it to reach the lowest energy state possible. Every single reaction that's taking place, whether it be something falling out of the sky, something burning, a nuclear reaction taking place, it's all just trying to get to the absolute lowest energy state that it can possibly attain. So with this in mind, let me have a look at the periodic table. Getting to the lowest energy state, or the most stable, which is another way of thinking of the lowest energy state, as far as electron configuration is concerned. So things with stable electron configurations are the noble gases. Now, if I stop for a second and go back and think about my ionization energy had this type of trend. And let me have a look at the things that had high ionization energies. Things like neon, argon, fluorine, oxygen, chlorine. Why did they have high ionization energies again? Because these ones already had octets or filled valence electron shells. Fluorine and chlorine had higher electron affinities because they were one electron away from achieving that noble gas configuration or that octet. So it was harder for them to lose electrons in order to gain that same configuration. Things like sodium and magnesium had lower ionization energies because it's easier for them to lose electrons to gain a noble gas configuration. So when I'm thinking of electron affinity, who is going to need those electrons? Well, it's going to be things like fluorine, chlorine, oxygen, sulfur, things like this. When they add electrons, they get closer to getting a noble gas configuration. Now there are quite a few exceptions for this, more so than in ionization energy, but don't worry about that for now. The important thing is to think about this in terms of valence shell electrons. Things that want to lose electrons to gain a noble gas configuration or an octet will have low electron affinities. Things that want to gain electrons will have high electron affinities. So with this idea in mind, what should the trend look like on the periodic table? Well, it should look the same as the ionization energy, because the reason that things had high ionization energy are for the same reasons that they're going to have high electron affinity, because they want to gain an octet. The reason they had high ionization energy is because they did not want to give up those electrons because they were either at an octet or they were very close to gaining an octet. Now, the reason for there being high electron affinity is because they are very close to an octet. Now, of course, it would not include neon. Neon and argon would have very low electron affinity as well, because they don't want an extra electron because they already have a stable electron configuration. If they were to add an electron, it would have to go into a higher energy orbit. So it doesn't want to add it. And things like sodium and potassium, they have some electron affinity, because if they were to add one, then they would fill up their orbital, but more likely they're going to want to give up an electron. It's easier for them to give up an electron to gain that configuration. So they're not going to want one either. And as far as the trend from top to bottom, that occurs for the same reason that the ionization energy decreases when it goes down, because of electron shielding. Because of the electron shielding, the ionization energy decreases because the nucleus has a harder time holding on to those outer electrons. Well, if it has a harder time holding on to those outer electrons, then what are its prospects going to be like trying to get new electrons? It's also going to have a harder time, so therefore the electron affinity decreases as well as I go down the periodic table.